We've got a few shortcuts in our arsenal. If we're at STP, we have an additional conversion. We know that 22.4 liters is equal to 1 mole. So here's how we solve it. If we have an equation, you're like, oh no, not equations. Yes, we have equations. Notice that we can solve PV equals to nRT for N. Remember that N is moles. So if we can solve this for moles, we can then use the molar relationship of 1 mole of hydrogen to 1 mole of zinc, then convert it to grams and figure out how much metal was consumed in the reaction. So let's see this in work. This is that N value solved for. So basically what it did was it just divided both sides by RT. So we take R, that's our same old R value. That's the temperature. It says STP. That's how we know it's 273.15. STP means 1 ATM. And then here we go at 2.15 liters. That was given in the problem. Notice there's no other numbers in the problem, and we can do so much math with no numbers, it feels like. So we get this number right here when we solve all of this in the calculator. And if you're not sure, everything cancels. Again, liters cancels, Kelvin cancels, and ATM cancels. All right, so now that we have that value, we can say moles of hydrogen, moles of hydrogen, moles of hydrogen, that's that number, compared to moles of zinc. And once we know moles of zinc, we can go to grams, and this part right here is from the periodic chart. Yes, we can combine any of those gas laws that have N in them with a reaction that's balanced. And that's how many grams were used to collect that much hydrogen gas. So that's one way to solve an ideal gas equation. I know it says with shortcuts. So that was a short way of solving a gas problem. I'll show you another way in a minute. It's right here. So is there a faster way? Can you use the fact that it's at STP? Yeah, you can. So we know that we have 2.15 liters of hydrogen gas. Now, we also know because it's at STP, you can only do that as STP, 1 mole is 22.4 liters. This is of the hydrogen gas, right? Oh, look, now we're in moles of hydrogen gas. Now we'll go from moles of hydrogen gas to moles of zinc, and then we'll go from moles of zinc to grams of zinc. And again, this was 1 to 1. Those were the coefficients. And then this is 1 to 75.28 grams of zinc from the periodic chart. You see how that's less math? Do you see how this is helpful and saves you time? So that's the first trick. This is called the STP trick, if you want. That's just my name for it. This is STP, though. STP and reactions. All right, now we're going to solve another problem 2 ways, the long way and the short way.